Did you know that thermodynamics is in everything we do? Yes, everything we do. The first law of thermodynamics states that the energy in a system must remain constant. In other words, energy cannot be created or destroyed. It can only be transferred from a system to another system. For example, like when you take a bath, initially the water is warm, but after sitting there for a while, the temperature starts to cool down. That is because the heat of the water transferred into the atmosphere into the body sitting in the tub. Another example is when you eat. We get energy from food. We then use that energy to do whatever it is that we do during the day. These two are pretty good examples explaining the first law of thermodynamics. But in this video, we will go in depth about the principles of thermodynamics in a gun and in a bullet.
There's several different types of energy in a gun-firing process. Kinetic energy is the energy due to motion. Potential energy is the energy possessed by an object due to its position. Mechanical energy is associated with the motion and position of an object. Chemical energy is the potential of a chemical substance to undergo a transformation through a chemical reaction.
These energies combine to launch a specific mass at a velocity out of the rifle. The energy transfer begins when the firing pin is released, hitting the primer, igniting the gunpowder, releasing chemical bond energy, which provides kinetic energy for the bullet. Different ammunitions will vary in velocity and kinetic energy due to different mass in the bullet and gunpowder used in the actual shell.
So now we're going to do a video showing the differences in these three weapons here. We're going to be shooting a 12-gauge shotgun, a 22 rifle, as well as a 223 rifle. We're going to start off by showing a slow motion video of just me shooting the gun and showing the cycle of the gun as it's shot, ejecting the shell, etc. Afterwards, we're going to take these three water bottles, place them down by the berm, and we're going to shoot each of the water bottles and show a video of the differences of the damages that each of the different weapons will do, just to kind of get an idea of the different velocity of each of the rounds. And since we don't have the access to technology to show the actual velocity out of the end of the gun, this is the best we can do. So we'll be shooting a water bottle with each gun just to kind of show the damage that each will do. So as you can see in the slow motion videos, we shot a water bottle with each weapon, and this is the damage that came of each of them. We started off shooting a 12-gauge shotgun, and as you can see, it messed up the water bottle pretty good. This is to be expected because a shotgun, unlike a rifle, has a bunch of BBs in there rather than just one bullet. And as you can see, this is what a bunch of BBs will do to it. We then shot the 22 rifle, and this is the weaker of the three. It's a smaller caliber gun, so it didn't do as much damage. It split the bottle, which again, not near the damage as a shotgun, but this is to be expected. We then moved on to the 223. It's kind of the same concept as a 22, except the 223 is a little bit faster round. It's a hotter round. It's going to be moving faster, and as you can see, it messed up the bottle tremendously more than the 22 did. The 22 just left a hole in it. The 223 ripped it in half. So as I said, each gun did what was expected. and this is the outcome.